Good evening, everyone. I am Rupesh H. Chaudhary of GM University, studying in 5th SEM and pursuing my BTech in CSE AM. So, this is my advanced machine learning presentation, and my topic is evaluate and compare the performance of two machine learning models using statistical methods. So, basically, I'll be evaluating and comparing the performance of two models over here, one of which is logistic regression and one is random forest model. So let's go. Team members, I alone am doing this project. So there is my name and USN over here. Introduction. So this project focuses on binary classification where we predict whether a person has diabetes or not. I am basically using FEMA diabetic data set over here. So it is a data set which consists of they say many lines of data of the people with diabetes. Basically, we compare two models, logistic regression, which is linear, and random forest, which is not linear. Not linear. The goal is to analyze performance using different statistical metrics. The main objective of this presentation or project is to train both models and evaluate them using five key metrics, which is confusion matrix, precision, recall, F1 score, and ROC AUC curves. Finally, we compare the results to find which model performs better overall. Logistic regression. Logistic regression is a simple linear model that predicts probability using the sigmoid function. It's easy to interpret and works well for linearly separatable data. However, it struggles when the relationship between features are non-linear. So you can see over here the sigmoid logistic formula and the advantages, which is that it works well with linearly separatable data and interpretable, and it is simple. It is not suitable for complex non-linear relationships. So the next one, random forest classifier. So random forest classifier is an ensemble model made up of multiple decision trees. Each tree learns from a random subset of data and features. This process is called bagging. By averaging the results from many trees, random forest reduces overfitting and gives us high accuracy. So there are many advantages. As you can see, it can handle non-linear data well, reduces overfitting as I said earlier, and it has high accuracy. And the limitations are complex and less interpretable and requires more computation. It usually requires more computation. So the data set, the description. So this is the description of the data set that I have taken. The FEMA Indians diabetes data set, which has 768 samples in it, in the sense 768 patient records with eight features like glucose, blood pressure, BMI, and age, etc. Our target variable is binary, one for diabetes and zero for no diabetes. The data set is slightly imbalanced, which makes evaluation more meaningful. So you can see the features over here: pregnancies, glucose, blood pressure, BMI, insulin, age, etc. And it is a basically a slightly imbalanced data set, which is ideal for making a comparison between the two models. So data pre-processing. So we load the data using pandas, mm, which is a Python. We replace zero with maiden values. We split the dataset into 80% for training and 10% for test and 10% for validation. and we apply standard scalar to normalize feature, and we ensure both, uh, in the sense, fair evaluation for both models. Conclusion: I'll show you the code right now over here after this conclusion part. Random forest, it has achieved the highest F1 score and ROC curve, and logistic regression remains a strong baseline for linear patterns. Using multiple metrics gives deeper insights than accuracy alone. Ansible models like random forest provide robust performance for medical data. So to conclude over here, random forests outperformed logistic regression in all metrics. However, logistic regression remains useful for interpretability and smaller data sets. Evaluating models using multiple metrics rather than accuracy gives a complete performance picture. So this is the presentation part. I'll next take you to the code which I have implemented. So this is the Python code. This is the main code over here. I have implemented the code in such a way that after implementation, I'll get the downloaded the PNG form of the results over here. You can see on the left side, and this is the metrics table. CSV is the uh, okay. So this is the data set that I have used over here. Once I run this over here, you can see it is at run right now. It is loading and pre-processing data set as you can see over here. After all this, over here you can see the value, the number of data sets which is loaded over here. It is checking the class distribution, training models, and evaluating it. The trains over here itself and evaluates over here itself. So basically, you can see over here logistic regression. It has calculated and given me the value over here itself. 0.6 is the precision. Recall is 0.5. F1 score is 0.545, and ROC AUC curve is 0.813. And same it has given for random forest also. So basically all the results are saved to folders called as results over here, as I said earlier. So I'll take you through the results also over here. So this is the confusion matrix of logistic regression over here. You can see. So uh, these are the names in the sense diabetes, non-diabetic, uh, yeah, over here, which has been predicted over here, and which are the actual values. So it predicts over here. Next is the confusion matrix of the random forest. So it is the same as the logistic regression. Over here is the ROC curve comparison. You can see over here. So the orange line over here is the AOC of the random forest, and the blue over here is the AOC curve of logistic regression. Those values are mentioned here properly. And the last is the matrix bar comparison. So this is the comparison of random forest and logistic regression. So yeah, this is my presentation, and thank you everyone. I'll wind up over here. Thank you.